Okay, so what they're giving you here is they're saying that people enter a line for an escalator at a rate modeled by this. Okay, so you do need to understand that this represents a rate, and it's the rate of entering the escalator, so getting on the escalator. Okay, and then if you read underneath, it says as people get on the escalator, they exit the line at this rate. So we call this like an in and out problem. So this is the rate of entry in, and this is the rate of out or coming off the escalator. Okay. All right. The other important thing that you want to look at is you can see that there are 20 people in the line at time 0. So at time 0, your escalator isn't clear to people. You have 20 people on it. Okay, so let's look at part A. So part A asks for how many. Now, guys, you have rates up here, and they're asking for how many. What are you supposed to be thinking that you should do? Okay, you should be integrating. And it says how many people enter the line from time 0 to time 300. So we're only looking for the amount of people that enter the line. Well, this is the rate of entry, so we would integrate because it asks how many, this rate. Okay, now it does say from time 0 to time 300, so look at these two domains here, and we're only going to be integrating this piece right here. Okay, so we're not going to be touching this part of the piecewise function because that deals with times that are greater than 300. Okay, so then basically all we're going to do for part A is we are going to integrate from 0 to 300. That R of t equation, and again, it's the one that's the top part of the piecewise function, and dt, and then just put this in your calculator. Okay, so you can put the top part of the piecewise function, this one right here, you can put this in your y1, and then just do math 9, and go about your business. Okay, now again, I understand that on your AP for this year, you won't have a calculator question, but the concept is what you're really going to need to understand. All right, so pause me and put that into your calculator and see what you get. All right, so you should get 270 people. Okay, so part B is saying that during the time interval from 0 to 300, there's always people in line for the escalator. So they want to know how many. Again, think about that. We have a rate in, and this is the rate coming off, and they want how many. So what are you supposed to be thinking? Integral, right? How many people are in line at time 300? So again, I am not going to be using this because this is after time 300. Okay, so the other thing though that we really need to look at is they gave you another little fact down here, and that there are 20 people in line at time 0. So we know that initially we have 20 people. Then we want to look at how many people are going onto the escalator versus how many people are coming off the escalator, right? So we're going, let me see, at time 300, right? So if we want how many and we have two rates, wouldn't we integrate from 0 to 300? And we would take the rate in versus the rate out, so to speak. Okay, so rate in minus the rate out. And that will give us the amount of people because we're going to integrate those rates. Okay, all right, so our rate coming in would be R of t, right, the rate going on to the escalator, minus the rate coming out, which would be 0.7. Okay, and then we're just gonna dx that. Okay, so again, let me just say that one more time. This represents the rate going on, and this represents the rate coming off. And this was the initial amount of people at time 0. Okay, well, we can put this all in our calculator because all you have to do is, if you already have this, right, I think from part A, in your y1, well, maybe just at the end of that, go back into your y1 and just write minus 0.7 and then math 9. Okay, see what you get there. Just that right-hand side. All right, so you have the 20 over here, right? Plus, and then what did you get when you put all of that in your calculator? You should have gotten 60. So that would be a total of 80 people. All right, so part C is saying for time greater than 300. So that is when we're going to start looking at that portion of R of T. And it asks what is the first time, so we're looking for time, that there are no people in line for the escalator. Okay, well, let's think about something. So if you go to your part B answer, didn't we find out that when the time was 300, we had 80 people in line, right? That was our answer from part B. So that's like an initial value. So at time 300, you have 80 people. So then what we're trying to figure out is still a rate in minus a rate out. Okay, so hold on, I'll explain more. Here's my rate in. Okay, here's my rate out. And if we're looking for people, I would still have to integrate, right? Because this is a rate and this is a rate. Okay, all right, so let me explain a little bit further. So I'm going to integrate starting at 300 and going up to some time that I'm really not sure of, right? Because time's going to tick past 300, 301, 302, 303, so on and so on. Okay, now we want the rate going in or onto the escalator, which in this case is 0, right? Because we are looking past 300, so we can't use this equation up here. We have to use this rate right there. Okay, so that's going to be 0 minus rate in minus rate out. Well, isn't the rate out 0.7? Okay, and then here we have dx. Are you following so far? Okay, so we are integrating because we want number of people, and this is a rate, and this is a rate. So when we have rates and we want number of people, we would integrate. So that's why we're integrating. We're integrating from 300 to who knows what, because they told us to look at values greater than 300. This is my rate in minus my rate out. Okay, now I'm not done. Okay, now this integral right here gives us how many people, but don't forget we have that initial amount from part C. So we really have to have 80 plus that. Okay, so we started with 80 people plus this. And what do we want all of this to equal? What do you think? What number represents no people? So we want this to equal 0, don't we? Okay, all right. So honestly, now this is a calculator question, so this is where it would be different for your AP exam. But I think the easiest thing to do would be to take all of this, plug it into your Y1 exactly as you see it. Okay, so you're going to type into your Y1 80 plus math 9, 300 to x, plug that in, and you're going to get a picture. And you basically want to see where that picture hits the x-axis. Okay, so again, all of this goes into your Y1. Get yourself a picture. See where it hits the x-axis, because that's what equals 0 means, and see what you end up getting. All right, so why don't you pause me and see what you have. All right, so I ended up getting an x value, which we really know stands for time. And I have 414.286. And that would be seconds. And there's your answer. So part D is we're back to that 0 to 300. All right, so we would be referring to this part of the piecewise function. And it says at what time, so we're looking for a time, is the number of people in line a minimum? Think about what the word minimum means. What does that mean we usually do when we have a minimum, or we see the word maximum, or we see the word increasing, or we see the word decreasing? Don't we take a derivative? Okay, so what I actually started with was, I was like, all right, you know what, let's back up. If I want to figure out the number of people, and I'm going to use people, PPL, in line, I'm just going to start with that. Because I know if I can get an equation for that, I can just take the derivative to figure out a rate. All right, well, we're going from time 0 to time 300. So remember here, initially we had 20 people. So that would be 20 plus, and we're back to that 0 to 300. And I am going to do the R of t equation minus 0.7, right? Rate in minus rate out. Okay, dt. And that would be my start, right? Okay, so if I want to find the minimum, if I want to find out when the number of people in line is a minimum, I would have to take the derivative, right? So I'm just going to call this like f of x. So then that would really just be f prime, wouldn't it? So f prime of x equals, well, we know that the derivative of 20 is 0. And if I take the derivative of all of this, won't this integral cancel out? So really then what I have is I have r of x minus 0.7. Okay, and I want to figure out, think about when we have a minimum, don't we take the derivative, which is what I just did here, right? So I took the derivative, and what do I usually do? Don't I usually set it equal to 0? So I can kind of do a sign chart or whatever. So I'm going to set this thing equal to 0. I have a calculator, and so basically I am just going to put this in my y1. Now remember, for the r of x, I'm putting in this value up here, or this part of the piecewise function. So I'm doing that whole thing up there, minus 0.7. Put it in my calculator and see where it hits the x-axis. Okay, so pause me and get yourself a picture. All right, so I have a picture and it looks like this. Okay, and this is the f prime picture that. All right, now let's just talk about the two zeros here. We're looking for a minimum. So remember, a minimum would occur when the derivative, which this is, right? This is the derivative. When the derivative goes from negative to positive. Well, doesn't the derivative go from negative to positive here? This, I would not look at this value because the derivative doesn't go from negative to positive. It goes from positive to negative. So this is the point that I'm really interested in. Okay? All right. So that being the case, I did do a sign chart. And we do have endpoints. We have 0 and 300. And then I have those two critical points, which again, I'm just going to point that out. This point does not matter to us because we know that that's going to end up being a maximum and we're looking for a minimum. All right, so that other point when you did second calc value, what did you end up getting? You should have gotten 33.0132. 0132. Okay, and so we know again that we've got minus, plus, minus. So then I know if I'm looking at my sign chart, we have minimums here at 33 point blah, blah, blah. But we also have a minimum here at 300, right? So it says find the number of people in line at this time. Well, we need to find which one's more min than the other. Well, here's the thing. I do know what f of 300 is, right? Because isn't that the answer really from part B? So let me just kind of see if I can squeeze this in here. So I know f of 300, and I know that that's 80 people. So what I need to do is find f of 33.0132. 0132. Okay, so that's what I need to find. All right, so let's go back to my f of x equation, which is this one right here. So basically, all I'm going to do is I'm going to do 20 plus 0, and I'm not going to go to 300. I'm going to go to 33.0132, put the rest of this in, and then just evaluate. Okay, so I'm going to say that again. So in your y1, I would probably put here, let's try that again. In your y1, I would probably put this. Now remember that your r of t is your 44 blah, 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 minus 0.7. That's in your y1. Then go to your home screen and do math 9 from 0 to 33.0132. Okay, so again, 20 plus the integral from 0 to 33.0132 of that r of t minus the 0.7. Okay, and I can't fin it, but you would write dt at the end. And work this out, see what you get, and then you're going to add 20 to that value. Okay, so why don't you pause me and see what you get as your final answer. All right, so your final answer should be 3.8034. Okay, so let's read the question again. It says, to the nearest whole number, find the number of people in line at this time. Okay, now let's go back. We have two options. Are we going to say it was 80 people? Or are we going to say it was to the nearest whole number? This would be 4 people. Okay, and they want to know when we have a minimum. Well, 80 is certainly larger than 4. So then your final answer should be 4 people. Okay, and that time would be at 33.0132. And I believe that that's seconds, right? Yes, seconds.